Mixed Kujal here. So today I'm going to be talking about regrouping and borrowing with bundled objects and why we're using this practice. This is some stuff you might have learned. Alright, so for one of the reasons why we use this is that it's really good manipulatives. I have these, and those manipulatives can also be transformed into pictures like I have here. Like right here, I have the problem 123 plus 87. These squares represent our hundreds. These tens represent, or these sticks represent our tens, and these little tiny squares or dots represent our ones. So they can better visualize this, and in the classroom, they can also move these around, so they can better see why. As you see here, since we have the 7 plus the 3, that has 10, so they can when they're learning, they can physically trade that in for a 10 stick. And in their drawings, they can change that. They can cross that out. I didn't on mine, but if they wanted to, they could cross that out and put a tens block. Same with these tens blocks changing into a hundreds block. And there are 10 here. During the lesson, if they wanted to, they could physically change out those 10 sticks into a hundreds block. In the drawings, they could cross that out and change it into a hundreds block like I have here. And it's just a really good way to just kind of introduce that concept of borrowing and adding, regrouping for them. And likewise, like I was just saying, with subtraction and borrowing. Like you can see here, we have 32 minus 17. Now these sticks represent our tens again. These dots represent our ones. So obviously we can't, we need to borrow one of the tens. Now like I said before, physically they could fit when they're using these manipulatives. Physically, they can change that 1 10 stick into 10 ones. So they can take the 10 1 cubes, and they can take that away. So they can take the ones away that are on the bottom. Likewise, they could do the same here. They could cross that out and make that into a tens. And so it's a really good way of showing them physically, improving to them why we do the algorithm that we do it. It's a physical way. Some kids learn better with physical manipulatives, and they can bring that on to the drawing and eventually doing the algorithms. As is, it's just a really good way to build that basis.